Okay, awesome. So yeah, thanks everyone for joining. The purpose would be today to do like a live walkthrough to the code and yeah, maybe answer any of the questions that you may have. And for the ones that yeah is the first time seeing the project, to have an idea about about the architecture, what is it, what it's about, and how the things work under the hood. So yeah, I will share my screen, and while I'm doing that, I also talk a bit about the structure. Let me know when you can see it. Can you see my windsurf?
Not yet.
Not yet. Okay. Wondering why?
I can see it. I can see it.
Okay. Okay. Perfect. Um. So yeah. First of all, thanks everyone for joining and also for taking the time to review it. In terms of the structure, the important part is, of course, the source folder and everything under the core. It's under the scope of the audit. Whatever is in vendor is mostly, interfaces or things that are used in core. So yeah, not part of the, main components. It's just something that we use, like third-party tools that we use. So in terms of the project itself, you can think of it as you also find in the README, is a modular protocol that allows dynamic execution and flexible composition of user operations via ERC 7579 modules. The 7579 is the standard for smart accounts. If it's the first time you hear about that, I recommend you look into it a bit before diving into the project, because that way you will be able to understand how things work under the hood. And it's gonna be much easier for you to spot any, I don't know, issues or understand the flow. The main idea with 7579 is that you have the account, which you can think of like your wallet, like a special kind of wallet on top of which you can install different components of different types. So like these components are like execution modules, validation modules, hooks, or fallback modules. Um, Execution modules, of course, are basically, as the name suggests, something that helps you execute different things. We also have this. Here is like sorry, someone is writing me that that stream is not working. Can you guys see it?
I can't. It's just instant, like always loading. But some people can. Maybe it's my internet.
I suggest for the people who cannot see to just disconnect from the stage and try to rejoin. I'm able to see a few others are as well. In
Okay,
any case, we're going to record this, so let's
It's
continue.
recorded. It's recorded, yeah. Okay, so the folder executor, as the name suggests, is for execution, and then actually let's start from this, because it's like the main point, like the entry point of the app. And once I show you the flow, we'll go into each component one by one. So the super executor and super destination executor that I'll be talking about at the end are the execution modules installed on top of the ERC 7579 account. And the flow starts from the execute method over here. So we have this service called Super Bundler, which is like the off-chain service that basically processes the intention of execution from the user and then sends them to the super executor. This one receives call data, which is of type executor entry, which is basically an array of hooks that are defined under this folder, and the same array length of hook data. So basically the data that is needed for that specific hook. And then we go into the process hook, and we have a few steps here. We have the pre-execution of a hook, the build step and the execution of it, then the post-execution, the update accounting, and lock for superpositions. Let's take each at a time. So I'm gonna cover first this part: pre-execution, execution, and post-execution. So let's go to hooks. Remember that initially I said that the 7579 account has different type of modules, one of them being hooks. Just a note here that those, just the name is the same. Those are not 7579 hooks. It's just, yeah, it's just that we named them the same. But they serve like a different purpose. All hooks inherit from the base hook, and I guess the most important part here would be the transient thing. Why we are using transient storage and not a permanent one is because we don't need to store any permanent data in hooks. We just care and we just need the data for that specific transaction that is executed in that moment. And to give you an example, let's assume I have a swap hook and a deposit to a 4626 vault. And was out amount used for this flow? For example, let's say I'm swapping ETH to USDC, and the deposit hook wants to use the previous hook result. So, I'm swapping 100 USDC into ETH. I get whatever amount of ETH, and then in the deposit for 626 hook, I'm using whatever the result of the output was to deposit in that specific vault. And for this kind of operations, we are storing in transient and we retrieve it in the next one. You'll see that in some hooks, if we go, for example, into, I don't know, let's see, approve, we have this use previous hook amount, and then we are calling the previous hook dot out amount to take that. What I said previously with that swap and deposit example. Okay, so let's dive into a hook. There are a lot of hooks here, so I won't go into all of them, but I'll just show you, the main idea of hooks. We have the pre-execution, the post-execution, and the build, as you've seen here in the executor. The pre and post executions are basically used to work with the transient storages. So, for example, in this case, in the post execute, we get the allowance that the account has for that specific spender to be used in the next hook is needed. For some other hooks, like for example a transfer, of course the out amount would be taken differently, would be retrieved differently. In pre-execute, we store the current balance of that account, and in post-execute, we perform the latest balance minus the previous one. This way, we can get how much was actually transferred. So basically, these are like the purpose of pre and post execute. And in the build, as you can see here, it receives a ABI encode pack data that is decoded. For this hook, it's pretty simple, but there are like other hooks, I don't know, let's say the bridge, where this is much more complicated. So depending on the hook, it can be pretty simple or not. In this case, it's just an approve hook, and as you can see here, after we perform, the validation, decoding, validation, and so on, we are building this execution array. The hook themselves do not execute the call directly. It just builds the execution array that is executed under the context of the account. And that's why we are not executing here directly, because if we were to do ERC20 approve of the token for this spender, the caller would be the hook itself, and we don't want that. We want everything to be executed under the account context. So if you look here in the executor, that's what happens here. We retrieve the executions array, and then we basically execute it. After this, the next step is update accounting, and this is related to, I would say, to simplify, to fees. Each hook has a type. If we go to approve the previous one that I showed you, this is of type non-accounting. But if we go to a 4626 hook, for example, a deposit one, this is of type inflow. A redeem is of type, where is it? Is of type outflow. In update accounting, basically what happens is that for inflow type of hooks, we register, the deposit amount, the obtained shares, the price per share at that moment, and related things related to that, to your specific operation on that time. And basically on outflow hooks, like for example in case of a redeem, that way we are able, with the help of ledgers here from the accounting folder, we are able to determine what was the profit of your flow and then take a fee out of that. There are a few caveats here, and also I recommend you to look into README and carefully read it, because there are some things acknowledged. For example, someone can say that he can define any hook that bypasses this fee structure, which is an acknowledged thing. I also saw some issues that are already added, which are already acknowledged in the README. So please take a look over that before diving into the code. Okay, let's go back here. So update accounting, as I said, is related to fees and how we process this, and we compute all of this stuff using the ledgers over here and the oracles. The oracles are the ones that basically retrieve the price per share and everything, and the ledgers are the one that determines the fee that needs to be taken and the profit that was made. And the last step in the execution flow is check and log for superposition. Like this is an optional step that is chosen by the user. If he wants, he can log his assets in a vault called Vault Bank, which is not part of the audit, but it logs the assets there and is gonna mint some superpositions on a desired chain that the user has chosen. And this is basically what happens in terms of execution. Of course, this execution has to also be protected by something, and that's why we have the let me go into it, the validator modules. Every time that when a flow is executed, it first goes through the validator module. We have the Super Merkle validator for the source chain validation and Super Destination validator for the destination execution validation. Basically, what happens is that out of all the data that the user sent, which is called a user up, which is called in user up in 4337, we create a Merkle root, and then we sign that Merkle root. And in the validators, before any operation is executed, it goes through validate user up, which decodes the signature data, decodes the execution data and everything. It checks if it's a valid Merkle tree, and then it checks if it's a valid signature. Let me show you that. Here it checks the Merkle tree, then it retrieves the signer and checks if the signer matches. If we have a valid proof, a valid user up, and this is also a cross-chain operation. Like for example, if we had a cross or a debridge or any other type of cross-chain hook that is defined in the flow, we also store the signature in a transient storage as well. That's because in a cross-chain flow, this has to be retrieved and appended to the message that is sent to a cross or debridge spoke pool. Okay, so now let me go a bit into the cross-chain flow. So if, for example, as I said, let's assume that we have an across send funds and execute on destination. This all the validation that I previously talked about happened already on the source chain, and then when it started to execute it, it's gonna reach this hook. And here, as I mentioned, we load the signature for this account and we append it to the destination data. And then we create the build execution, which targets the spoke pool deposit v3 now. In terms of recipients, we have these things called adapters, which is per protocol, of course. Let's look into the across v3 adapter. For anyone who is used to across v3, you'll see that this is the method that you need to have on your contract to be able to receive an across call. So these adapters here are like gateways on the other side, on the other chain, to process the message. So in case of an across bridge call, this one will be called here by the relayer. We decode whatever we received, and this is a specific layout. This is the layout for any cross-chain operation. Like all of them has to contain this in the destination message that is sent, which is the init data. This one helps to create the account on the destination chain if the account does not exist there. We have the executor call data, which is the data that needs to be executed there. The account, which this one has to match. If, for example, this is address 0, this has to match here. The destination token and intent amounts. This is something that basically, if I have a complex cross-chain operation, let's say I want to receive USDC and WET on the other side, and I want my execution to be performed only when I received everything. Let's assume I'm sending from like 3 chains. I'm gonna go into the super destination executor. You'll see that part checks if the balance of the account has all the tokens needed for the execution, and only starts the execution when all of these were received. Otherwise, it waits for the other, for the rest of the funds to arrive as well. And the SIG data, of course. Then we send whatever across sent here to the account, and then we call a super destination executor process bridge execution. And if we go into this one, in the process bridge execution, check over here. We first create the account. If it's not created, we are using the Nexus factory to do that with the init data that is provided. Also want to mention here that there was a issue added on this, saying that this can change, and then anyone, like any malicious actor, can put anything in the init data. If that happens, the computed address here will be different, and this check won't be valid, so it will revert. So you cannot change whatever is in the init data. Okay, so it creates the account. If it doesn't exist, gets the Merkle root from the signature, creates the leaf that should be part of the Merkle root, and is using the super destination validator to validate the call. If everything is good until here, then it goes to validate balance. And this is something that I previously, that it waits for all the funds to arrive here before it starts to execute. If everything is alright, it marks this Merkle root as used, and then if there are executions, starts to execute them using the execute from executor, which is a method on top of the 7579 accounts. I think that's it in terms of the flow. There's one more thing here that I can talk about, which is the paymaster, which is like the main entry point of the application. So basically, like bundler won't call the super executor execute method that I showed you earlier directly. It's gonna go through, so this is the execute. It won't call this directly. everything is gonna go through the super native paymaster handle apps, which later on calls the entry point, the 40337 entry point handle apps to execute that user operation. We have these to allow paying in any ERC20. Then the super bundler, sorry, the super bundler off-chain service that I mentioned earlier will be able to swap these tokens and then call the super native paymaster to execute the operations. Yeah, I think I covered the flow, like the main flow for it. Now, if you have any questions, please, I don't know how this usually goes. I guess you can write them in the chat and yeah, we can answer. Or Time Punk, if you have any additional things that you want to say, yeah, please go ahead.
I think we covered quite decently the contracts. Maybe she could say a few words just about this off-chain service, the bundler, as it can impact the way you review this code and some of the stuff that we consider to be acknowledged given the assumptions around this bundler.
Yeah, so as Cosmin mentioned, like most of our backends, like most of our hooks are kind of bundled by the super bundler, which is this service that also maintains a registry. So something that we'll kind of acknowledge is like any kind of selection of hooks, any kind of like hooks registry, it's maintained purely off-chain on the bundler, and the bundler is responsible for like creating a proper list of hooks with proper chain list of hooks, and the user is presented with that and the user signs over it. So any kind of control over what hook is executed lies with the bundler. Also like stuff around how the account data would be created and how the kind of off-chain interaction is done, those are controlled by the bundler itself, and again it is present to the user, and only after user signs the stuff goes through. So like those are the assumptions that we are doing, where the bundler is the kind of only entity who has the control over selection of hooks and also proposes them to the executor. So yeah, that's an assumption that we do. Additionally, also something that might come up during the review, like basically when accounts are created and kind of accounts are created using the Superform modules, we use we have a very different kind of a signature methodology where we use our own validators for kind of validating the signatures. They work kind of very similar to how in general 437 user of signature validation works, but we have introduced additional kind of parameters with them. The job of creating this signature, like sig data, also lies with the bundler as per like proper values, and so the user signs over it. But again, like if the user is going outside the bundler ecosystem and like going outside the Superform app itself and signing something on his own, the risk lies with the user. It's similar to the user signing anything malicious to be executed on its smart account, like a malicious user operation. Yeah, those are pretty much it, I believe. Joe.
Yeah, all right, we'll drop. Thank you guys. We'll talk later in the chat and in the Cantina tool. See you.
Bye.